Okay, let's have a look here. Use De Morgan's theorem to calculate z power 5. So, B part 1 here. Z is minus 1 plus I. So it's up here in the second quadrant. And the modulus of it is root 2. So the z would be root 2 cos, and then that angle there is 135 degrees plus I sine 135 degrees. So Z5 would be root 2 power 5, and then that one would be cos 675, because remember De Morgan says that the power actually multiplies the angle, plus I sine 675 degrees, which is cos 675 is root 2 over 2 and then the sine 675 is minus root 2 over 2. So that would now be root 2 power 6, which is 8, isn't it? When take the root 2, that's 8 over 2, 4. So that's 4 minus 4i. And then likewise, Z9 would be root 2 power 9. And then this would be 135 times 9. So that's cos 1215 degrees plus I sine 1215 degrees. So that would be root 2 power 9 minus root 2 over 2 and plus root 2 over 2i. Take the root 2 out, that would be root 2 power 10 root 32, yep, 32, divided by 2, so that's minus 16 plus 16i. So that means Z5 plus Z9, minus 16 plus 4, minus 12, and then plus 12i, which is equal to 12 times minus 1 plus I, which would equal 12Z. So that's proven. I've accidentally done part 1 and part 2 at the same time. Okay, there's part 2 there, I guess. Didn't realize it. Now, the next part is we want to solve this equation and use it to solve the second one then. Yeah, so we've seen one like this before. What's going to happen is this quadratic will produce a root 15 plus 8i. So that's why this part will be useful for the second part. So let's have a look at that. Okay, so if I expand here, I get a squared plus 2abi minus b squared equals 15 plus 8i. So that means AB should equal 4, and also a squared minus b squared, a squared minus b squared should equal 15. So that means a squared minus b squared, which would be 16 over a squared, is equal to 15. If you multiply by a squared, you get a4 minus 16 equals 15a squared. So that is a power 4 minus 15a squared minus 16 equal to 0. I can factorize that. That's a squared minus 16 and then a squared plus 1. This can never be 0, so it means a equals plus or minus 4, and then b is 4 over a, so it'd be plus or minus 1. B is 4 over 4, which is 1, or 4 over minus 4, which is minus 1. So it's going to be 4, 1 or minus 4, minus 1 as the two possibilities here. In other words, plus or minus 4 plus I. That's the root of this complex number here. The two roots are plus or minus 4 plus I. Let's solve this quadratic now. Minus b plus or minus the square root. And I feel like cheating and just writing in 15 plus 8i, but let's check that we do get 15 plus 8i. B squared, so that would be b squared, which is 4 minus 12i plus 3i squared, plus 3 squared I squared, which is minus 9. So that's b squared minus 4ac, which is 4i times this. So minus 4i times minus 5 plus 5i. So that would be plus 20i minus 20i squared. Plus 20i minus 20i squared. Minus 20i squared, which is plus 20 then. 20 minus 9 is 11, plus 4 is 15. Excellent. 20i minus 12i is 8i. Excellent. All over 2a, which is 2i. So this would be minus 2 plus or minus 3i all over 2i plus or minus 4 plus I. If I multiply above and below by I get minus 2i. Oh, sorry, I shouldn't have written, that's not plus or minus, that's just plus. Minus 2i plus 3i squared plus or minus 4i plus I squared all over 2 I squared, which of course is minus 1. So let's put in the plus answer first. So positive, we have 4i minus 2i is 2i, but then 2i actually, what am I doing? I should do the real part first. So that's minus 3. That's minus 4. Minus 4 over minus 2. Oh, I can't do this in my head. I'm going to make a mistake. I know it. Can I erase this box here? Yes, I can. All right. Let's not make a mistake at the last hurdle. That was equal to minus 2i minus 3 plus or minus 4i, and then that's minus 1. Minus 1 times plus or minus is minus or plus over 1 all over minus 2. So if you multiply by minus, you get 2i plus 3 minus or plus 4i plus or minus 1 all over 2. So let's take the top first. 3 plus 1 is 4. 2i minus 4i is minus 2i over 2. So that's 2 minus I. Or we take the bottom one. 3 minus 1 is 2. And then 2i plus 4i is 6i over 2, which is 1 plus 3i. Okay, that looks like the two roots. Hopefully I didn't make any mistake.